So good morning. Section 10.9 is going to talk about graphing systems of linear inequalities. We're going to start out by just graphing regular linear inequalities, get used to graphing those, and then we'll step it up a little bit and start talking about systems of inequalities. As far as graphing linear inequalities, that's going to be stuff like example D here, where we've got y is less than negative 7x. The way I suggest you start this is by first graphing the corresponding equation. So our first step is to graph y equals negative 7x. And I'm just curious, if you were asked to graph y equals negative 7x, what would you do? How would you do it? Put it in your calculator? Okay, not bad. If you needed to put it down, like say on some paper, actually have a decent looking graph, then what would you do? You could still probably get something off your calculator. There's a couple ways that you could think about graphing this. One would be to recognize that this is in slope-intercept form. It's really y equals negative 7x plus 0. What's the slope of this line? Yeah, the slope is negative 7. Well, negative 7 over 1. And I hope that you remember slope is rise over the run. So you can start out with the y-intercept. What's the y-intercept in this graph? Yeah, the origin, 0, 0. So you can start out at the origin, 0, 0, and then move over 1 and down 7. So that would put you, about right here. And then you move over 1 and down 7 again, and you've got a line like that. Alternatively, if you don't have a line that's in nice slope-intercept form like this, you could always just plot some points. So you could just do this. Let's do a little t-table. Pick values for x, and then get values for y. So always start with 0. That's pretty nice because you get the y-intercept. In this case, it's 0, 0. If I plug in, say, a 1, negative 7 times 1 is negative 7, 2, negative 14, negative 1, 7, etc. Now, I only need 2 or 3 points to be able to graph a line. I do suggest 3, because if you make a mistake, then you get a triangle of points rather than a nice line of points. One of the things to keep in mind about graphing an inequality like this is we want to use the proper line. So if you have a less than or a greater than, use a dashed line. If you have a less than or equal to or greater than or equal to, use a solid line. So do take care of that because that is a point of credit when I grade your exams. So we want to draw a dashed line here. That looks pretty good. I'll draw little arrows on either end there. Now the thing about this is it's not just a linear equation, it's a linear inequality. One side of this or the other is going to satisfy the inequality. So you're going to end up shading an entire half plane of this graph. The question is, which side do I shade? Well, I put in the instructions that the side you want to shade is the side that makes this true. Well, how do we know which makes this true? Well, that's where we're going to test a point. And our restriction about testing a point is it has to be something that's not on the line. Unfortunately, our line goes through 0, 0, which is typically my favorite test point. So we can't test that one. But there's quite a few other choices. Can someone give me a point that's not on the line?
1, 1.
Yeah, all right, so let's put in 1, 1, which is going to be somewhere around here. So we'll test 1, 1 in our inequality. Thank you, Charles. So second step, test 1, 1. Sure, let's test 1, 1. So that's your x and your y. We're going to test it in the inequalities. So we're going to put in a 1 for y and a 1 for x. Is this true? Is 1 less than negative 7? No, that's false. Now, if you wanted to be really thorough, you could test the other side of the line, something down here, and it should test out true. However, it will test out true. What I'm going to suggest to you is you really only need to test one point. If it tests out true, you shade that side of the line. If it tests out false, you're going to shade the other side of the line. So in this case, since it tested out false, we're going to shade the other side of the line. So your final graph should look like this. If you want to make it a little bit more dense here, that's fine. But just something that lets me know that you're shading this side of the line, and we're good. That's your graph of this linear inequality. Not bad, not bad. Let's move on to example E and talk about a couple basic graphs that you should, hopefully be pretty comfortable with, if not familiar with. Let's move on to y is greater than or equal to 4. Okay. Well, the first thing we're going to do is we're going to have to graph y equals 4. Can anyone tell me what that graph would look like? Yeah, a nice horizontal line. In fact, you could think of this again as being in slope-intercept form. It's 0x plus 4. So 0 slope is going to be a horizontal line, and it's going to go through y equals 4. Cool. Should I use a solid line or a dashed line to graph this? Solid. Thank you. Solid line. So let's just draw a nice solid line through there. And let's see, we'll use a different color just for variety. So there's your solid line. Now we want to shade the appropriate side. You could test a point. In particular, 0, 0 is my favorite test point. So if I put in 0 for x, well, there's no place to put in 0 for x, is there? So I'll just put in a 0 for y. Is 0 greater than or equal to 4? Is that true or false? That's false. So I want to shade which side of the line? Do I want to shade below or do I want to shade above? Above. Now let's look back at this a little bit and do a little thinking. Did we really need to test a point on this particular one? No. We can kind of eyeball, well, y is greater than 4. That's going to be things that are north of this line, above this line. So we probably could have gotten away without really testing points on that one. Not so much on this one, but definitely on that one. So with that example in mind, why don't you see if you can do this one? And maybe do it without testing a point if you can. If you're watching this later, then maybe pause the video to try and graph that. I'm going to walk around and see what you guys think about this one. All right. Looking good. So first things first, you're going to graph the line x equal -6. That's going to be a vertical line. Should I draw that with a solid or dashed line? Solid line. So let's draw a nice solid line there. And let's see. Do this one in green. Solid line through -6. Which way am I going to find points that are less than or equal to -6? To the right or to the left of this line? Less than is going to be to the left, so I want to shade just this little piece right over here. And bam, we're done. Yay, not so bad. So, graphing linear inequalities, this hopefully is a little bit of review, but the real title of the section is Systems of Inequalities. And you should be starting to get used to this idea of systems. When we solve systems of linear equations, we were trying to find where they overlapped. And we had more than one, we had multiple equations or planes at the same time. We tried to solve them simultaneously. Same thing with nonlinear systems. Nonlinear systems, we're trying to find where those curves intersected each other. Where do they overlap? Same thing's going to be true with systems of linear inequalities. Or excuse me, yeah, systems of linear inequalities. We're going to try and find where these things overlap. So let's take a look at a couple up here. For instance, x minus y is greater than or equal to 0, and x plus y is greater than or equal to 3. So I've already drawn these for you, but maybe you can try and figure out, before I spill the beans, which graph is which. Because we have to graph two graphs. One of them is x minus y equals 0, and the other one is, let me do that in a different color here, x plus y equals 3. So see if you can't figure out which one is which of these two graphs. Any guesses? Which one is this one right here?
X plus y is greater than or equal to 3.
Yeah, so this is the equation x plus y equals 3, and then we'll finish graphing it. Thank you so much. So I'll draw that one here in red. Then obviously this one has to be in blue. Kind of one way to see that this is the graph of the second one is to realize that this is the same thing as x equals y. And x equals y is going to be a line that bisects the first and third quadrants. All right, so we've got our lines drawn. Thank you so much. Let's figure out what side of this line or this equation we're going to shade. So let's see. Well, I can't quite use 0, 0 as a test point for this line, so I got to use something else for that line. Let's pick another test point. Any suggestions? Jaden, suggestion? What test point could I use for this line?
0, 1.
All right, so 0, 1 is going to be right up here. So that's going to be my test point. So we'll test 0, 1. 0, 1. And let's see what happens there. Now we're going to test that in this inequality. So let's see, you put in the x, 0 minus 1, is that greater than or equal to 0? Is that true or false? That's false. So what we're going to do is we're going to shade the appropriate side. Now what side is the appropriate side? Is it the side above this blue line or the side below that blue line? Well, this tested out false, so I want to shade the other side. So I want to shade down here. But keep in mind, this is a system of inequalities. So I want to see where these things overlap. So I've got to do another test point. Now I could use the same one if I want. Doesn't matter because this point is not on either line. I could use 0, 0. But I want to test it in this inequality. So what test point do you want to use? It's up to you. Eric, suggestion. What's your favorite test point for this one?
2, 2.
2, 2? All right. 2, let's see, let's just make sure where that is on this graph. So 2 is on this line, but that's okay. I was just trying to make sure if it's below or above that line. So 2 would be about right here. So let's test 2. Is it? Is that? Oh, that's a 2. All right, I was looking at that and thinking it was a 3. So that's a 2. So 2 would be this spot right here, right? Okay. You can do 0, 0. That one's pretty. So 0, 0 is certainly pretty clear. Pick whatever test point you want, and let's test it in this inequality. I'm going to go with Eric's suggestion, 2, 2. I do think we've got that plotted right. 2, 2 should be up there. Let's see, test 2, 2. Is 2 plus 2 greater than or equal to 3? Is that true? Yeah, that's true. So if that's true, where do I want to shade? Do I want to shade below or above this red line? Above. So let's do that as well. So let's shade here above. Now let's keep in mind the system part of these types of problems. So the fact that we're working with a system of inequalities means we want to see where these are simultaneously solved. Where do they all overlap? And they really don't overlap just everywhere. They overlap right here. So what I'm going to want to see from you on your exams is something like this where you've indicated that, yeah, this region where they overlap, that's our solution to this system of system of inequalities. That's where they all overlap. Now there's a different way to do this. It's kind of up to you. One of the cool things about Desmos, did I ever mention Desmos? That's kind of a cool thing. So let's take a look at Desmos real quick. There should be a link out on D2L for this. And is that it can graph inequalities. Uh-oh, that's telling me something different here. Okay. That's example C. Let me go up here to example B. There we go. So you're seeing the same thing when you're graphing this. By the way, if you are going to graph this on Desmos to double check your answers or something like that, what you can do is you can change the color of the shading here. Pick whatever colors you like. I like working with orange because it's a light enough color that you can still see things when they overlap. But it's up to you. It still works, and you can see that this shaded region where they overlap is what counts. All right. Let's work with that same kind of system again, except I made a little bit of a change. Can you see the change that I made from example C to example D? What's the difference there?
The sign has changed from the top equation.
Yes. So in the top equation, instead of a greater than or equal to, I've got a less than or equal to. So the bottom equation should be the same. Excuse me. So the bottom equation, or inequality, is the same. So I know I'm going to shade above for that bottom inequality. And what I'm going to do is just do a little something like this. I'm just going to write a couple little arrows like that saying, oh yeah, I'm going to shade above on this one. Now if I flip the inequality here, instead of going down with my shading, where do you think I'm going to go up? Where do you think I'm going to go with my shading by flipping the inequality? Yeah, tell you what, we'll look at it on Desmos. Make it a little bit more visual here. So in this graph, I had to shade below the line, but when I flip the inequality, I end up shading above the line, which makes sense. So let's shade above the line. Now I'm not going to actually do the shading here. I'm just going to draw a couple little arrows here. And what I want you to do is use your mind's eye to look at this and think through it and figure out, well, where are these shaded regions going to overlap? Where am I going to see these things cross each other? And just shade that portion. Don't shade the whole thing, just shade that portion. Where do they overlap? Rush it. All right, so where should I shade? Where are they going to overlap? Where's the solution?
The top.
Yeah, the top. So I'll give you two ways you can work these things. One of them is to just shade everything and then circle where they overlap. The other one is just to say, okay, I'm just going to shade where they overlap. So either way works for me. One way or another, you're telling me that you recognize the solution is where these things cross each other. That's the big part. Now, this kind of stuff leads into something called linear programming, which was a branch of mathematics that was developed a lot during World War II because you had to maximize things like production of armaments and things like that at a time with limited resources. You had a lot of people in the army fighting a war. You had to be careful about your production of goods and things at home. So you tried to maximize things under constraints. And those constraints are these types of inequalities. Another thing that they did was they tried to figure out the configuration of guns that we would put on planes so that you could bring the maximum amount of firepower to bear on enemy aircraft. So a lot of applications of this stuff. We'll see that in the next section. But let's continue with some inequality stuff, some inequality work. And let's see, which one do I want to... let's flip over to the back and work with example G. Now, I'm not sure if and when you've seen the graphs of circles, but this is a nonlinear inequality. You are going to start the same way. You're going to start with x squared plus y minus 2 squared equals 4. And that's a graph of a circle. If you look at what makes the squared terms equal to 0, the center is at 0 for x and 2 for y. What's the radius of the circle? 2. So the radius, that's the square root of the right-hand side. Square root of 4 is 2. So you can see the center at 0, 2. You can see the radius is the square root of the right-hand side. What mistake did I make in drawing this? Yeah, I should have a solid line as opposed to a dashed line, so shame on me. Okay. So there's my graph. I've got to decide where I want to shade. Do I want to shade inside or outside of this inequality? Good question. Good question. How am I going to answer that question? Where I want to shade, inside or outside? Yeah, with a test point. So what's a good test point? Can I use 0, 0 as a test point? No, because that's on the line. But there's quite a few other ones. Can I use 0, 2 as a test point?
Sure.
Yeah, nothing wrong with that. I mean, it's not on the line. That's the only requirement. So if I do that, it's going to be, let's see, 0 squared plus 2 minus 2 squared. Is that going to be less than or equal to 4? Well, is 0 less than or equal to 4? That's true. So take a moment and shade the appropriate side of this graph. Where are you going to shade? Adrian, where do you think we're going to shade? Inside or outside the circle? Inside. Yeah, well done. So looking good. Nice. Why don't you take a moment and try the other one? Try this one. Again, a circle. This time I was correct in drawing a dashed line. Decide where you're going to shade. I'm curious what you guys use for a test point. I mean, I know my favorite test point. Yeah, 0, 0. Why not? Right there in the center. So is 0 squared plus 0 squared greater than 9? No, that's false. So where do I want to shade? Outside. Thank you, Brooks. So we're going to shade outside. There we go. Done. Nice. Now what happens if you don't remember what some of these graphs look like? For instance, here we're going to start by graphing the equation negative x squared plus y equals 3. If you don't remember what that looks like, what might you do?
Make it so it's y equals.
Yeah. Yeah, you could move that to the side and get y equals x squared plus 3, and you can put that in your graphing calculator. You see it's a parabola that's been shifted up by 3 units. So again, the goal is to decide, well, where are you going to shade for something like this? Okay. And I'll leave that part up to you. So once again, an easy test point is what? 0, 0, yeah. As long as your graph's not going through the origin, 0, 0 is a nice friendly test point. So plug that in for x and y. Negative 0 squared plus 0, is that greater than or equal to 3? Is 0 greater than or equal to 3?
No.
False. So this tested out false. So where do I want to shade? Carla? Where do I want to shade? Inside or outside of my parabola?
Inside.
inside. Yeah, well done. So let's just shade everything in here. That's good enough. Looking good. Thank you. All right. One last one that's getting closer and closer to our linear programming stuff. I'm going to start out by asking you to think about these two inequalities. Y is greater than or equal to 0 and x is greater than or equal to 0. Now think about it relative to what we did here. Y is greater than or equal to something that was a horizontal line we shade above. X equals something as a vertical line, and then you have to decide if you're shading left or right. In this case, it was to the left. But think about these two right here, and try and envision where those two graphs are going to overlap. Where is x greater than or equal to 0 and y greater than or equal to 0? Where are they going to overlap? Where do those both intersect? And while you think about that, I'm going to pull this up on Desmos. Let's see here. Actually, yeah, I'll just have to put it in, I suppose, kind of manually. Greater than or equal to 0, and y greater than or equal to 0 again. All right, so where are these things going to overlap? Any suggestions? Charles?
Positive.
Yeah, they're both going to have to be positive, so what quadrant is that going to be? First quadrant, yeah. And if you think about it, everything in the first quadrant is going to have positive coordinates. Positive value for x, positive value for y. So in answer to the question that's on our handout, why is this graph just drawn in the first quadrant? Because wherever these things overlap is going to be in the first quadrant. It has to be. A lot of times these are called the natural constraints. That's because these things arise naturally. When you're talking about production or something like that, you only have a positive amount of material to use or a positive amount of man hours to use, etc. So a lot of times these just arise naturally as a condition of your problem. So we've got two other parts of this inequality. We've got to shade both and see where they intersect each other. As far as graphing those is concerned, well, let's take a look here. We've got y equals negative 2x plus 6 and y equals 1/2 x plus 3. As far as the graph is concerned, let's do this one with slope and intercept and try and figure out which one this one is. What's the y-intercept in this graph? 6. So there's your y-intercept. And right away that tells us which graph this is, right? There's only one of these that has a y-intercept of 6, so it has to be this one. So, okay, great. Let's see. I'll draw that one with a pink line right here. For this one, well, maybe you want to graph these things by plotting points. If that's in your comfort zone, that's fine. I'd always start out with x equals 0 because that gives you the y-intercept. So 0 goes with 3. And then because this is multiplied by 1/2, it might be convenient to choose even numbers. For instance, a 2 for x. What happens when you take half of 2? You get 1. And then when you add that to 3, you get 4. So 2 and 4. So there's your other graph. Bless you. I'll draw that one in orange. And what I'm going to leave up to you is deciding where you want to shade these things. So you can use 0, 0 as a test point for both of them, but you do have to test both of them to figure out where you're going to shade. So decide if those are true or false, decide where you want to shade, see if you can't come up with your solution. Okay, so let's see what happens. If I put in 0, 0 here, is 0 less than 6? Is that true? Yeah, that's true. So we're testing this line. Which way do I want to shade? Do I want to shade below to the left or above to the right for our pink line here? Below here. Because 0, 0 is our test point, it's on this side of the line. I want to shade the true side, so we're good there. How about the other one? Is this true? Yeah, that one's also true. So because this point is on the underneath side of this line, I'm going to shade below like that. These shaded regions overlap right here in this little area adjacent to the origin in the first quadrant. So let's just shade all of this. Now there's nothing wrong if you wanted to do the shade everything kind of approach and then just see where they overlap. The one thing that if you're shading everything and just seeing where they overlap, what I would ask is that you circle it when you're done to let me know that you understand that the shaded region, or where the shaded regions overlap, that's your solution. Nice. How are we looking on those? Is that as easy as it seems? Yeah? Got this? All right. Cool.